Evening, sir.
Very good evening. How are you, Nitish? How are you, Kangu?
Fine, sir.
So, is the screen visible to you?
It is with me.
Well, can you see the
Yes, sir.
screen? Very good evening.
Evening, sir.
Very good evening. How are you?
Fine, sir. Hello.
Yeah, yeah.
Yes. So, can you tell me what we have studied? We were studying the preparation of hydrogen, right?
Preparation. No, I think. Yeah, sir.
Exactly. Then we have also discussed two of the properties of hydrogen, right?
Yes, the properties colorless, odorless, tasteless, slightly soluble, highly
Exactly.
inflammable, like that.
Yeah.
That's
So that means we are just seeing the
so we also saw the reaction with metals and reaction with non-metals.
exactly. So that means we have to now see the next one, right? So next we are going to see that is reaction with metal oxides. Reaction with metal oxides. So this hydrogen, it also reacts with metal oxides. For
Yes.
example, if we are having, let's say, zinc oxide, and I'm reacting it with hydrogen, dihydrogen, that reaction.
They
Can you
were.
tell?
Sir, this doesn't work. Sir, this won't work. Sir, this won't work,
Why
right?
not?
Because
It will,
zinc is
sir.
more reactive than hydrogen.
No, no, it is
What?
not just. If it was hydrochloric acid and here it was zinc, then we will see that the reactivity. But actually, here it is only hydrogen gas. What it is acting as? It is just acting as a reducing agent. It will just reduce this zinc oxide, so it will form zinc, and we
So
will get the
zinc
water.
hydride plus
Oh, zinc plus H2O.
Yeah, zinc plus H. That means this H2 here acts as a reducing. It acts as a reducing agent.
yes,
So that means zinc oxide, it has actually undergone reduction.
yes, and hydrogen has gone oxidation because oxygen is
Exactly.
being
Yes, sir.
Hydrogen has actually undergone oxidation. Correct. So you have to remember opposite. That which undergoes oxidation, that will act as a reducing agent, and that which undergoes reduction, that will act as oxidizing agent. Right? Yeah, this is very important. I'm again repeating it, that the substance which undergoes oxidation, that will act as reducing agent, and
okay.
similarly the substance which will undergo reduction, that will act as oxidizing agent. Got it?
Yes, sir.
Yeah, this is very important.
Yes, sir.
So I hope that now you can tell me the products in these reactions. For example, let's say I'm having copper oxide and I'm treating it with hydrogen.
Copper plus water.
Yeah.
Yeah, will give you copper plus water. Exactly. So can you tell me here which is the oxidizing agent and which is the reducing agent?
The H2 is the
So copper
reduction
is the
agent.
oxidizing agent
Co-
and hydrogen is the reducing agent.
Hydrogen is the reducing agent. Exactly. And this copper oxide will act
oxidizing
as a
agent.
oxidizing agent. Correct. So these reactions are very simple. I hope you can answer. For example, if I'm just giving lead oxide, PPO.
Pb plus H2O, and Pb undergoes is oxidizing agent and H2 is reducing agent.
Exactly, Sam. That is, you will get here the lead and you will get here the water, and hydrogen is your here the reducing agent, or what you also call it as reductant. A reducing agent is also known as reductant,
Yep.
right?
Yep. Yes, sir.
Yeah. And similarly, this will be your oxidizing agent, or it's also known as
Oxidant.
oxidant, right?
Ooh.
Okay. So that means you have to remember that these oxides, they are actually getting here, they are getting here reduced with this
Yes, sir.
hydrogen. Hydrogen acts as a reducing agent.
Yes, sir.
Okay. Now there is another also
So does
another way.
that mean oxygen alone? Okay, nothing.
See here, zinc. It was zinc oxide, right? It was
Yes.
zinc oxide.
Yes.
Now it has changed now into zinc. So that means it has lost oxygen. So loss of oxygen means reduction. So zinc oxide, it has undergone reduction.
Yes.
Got it? Okay. Now the next reaction which you will remember here, that is reaction of hydrogen with carbon monoxide. Carbon monoxide, if it reacts with hydrogen, there are certain conditions which I will write it here. Number first is the high temperature, that is 700 Kelvin,
So what is
and
this
high
reaction with
pressure.
monoxide?
Yes, carbon monoxide plus H2,
Oh,
hydrogen.
only carbon monoxide or any monoxide?
Yeah, it's only carbon monoxide. So can you tell me what will be the product here?
Carbon plus water?
No, there
No,
is
this is
actually
coke and water, right?
this is not coke. This is just carbon
This is
monoxide. It is
water gas,
carbon
right, sir?
monoxide.
Yeah, this is
Water gas.
Exactly, you have studied water gas. So
Yeah, that means
if
it'll give. Okay.
if you are having this high temperature, high pressure, and this zinc and chromium oxide, they act as catalyst, it results in the formation of alcohol, very important alcohol, that's your methanol, that's CH3OH.
Yes.
This reaction is very important. I hope you will remember this. Methanol will be formed.
Yes.
yes, sir.
So that means you can prepare this alcohol methanol by treating this carbon monoxide with hydrogen at a very high temperature, that's 700 Kelvin and 200 atmospheric pressure, in presence of zinc oxide and chromium oxide, which act as catalyst.
Yes, sir.
Got it? Okay. So shall I move to the next page? Have you noted down this?
Sir, wait, sir, almost done.
I finished it. Yes, I finished it.
Sir, I'm in the last reaction, sir.
Okay, okay, fine. You can note it down.
Sir, why does the fourth reaction need two two what is that? Catalysts. Why
Catalyst.
does it need
Catalyst.
two catalysts, sir?
See, sometimes
Oh,
actually Sometimes some reactions require more than one catalyst. Actually, what happens? One catalyst it increases the surface area, and another catalyst it actually increases the efficiency of first one catalyst, and
Is
both
that
actually
okay?
both
Isn't that a
actually enhance
promoter?
the rate of reaction.
Oh,
Both enhance the rate of reaction.
so but if one of them increases the efficiency, isn't that technically a promoter?
Exactly. The technical term is the promoter, but here we call this mixture as a catalyst here. The
Yes,
So
sir. You
that
texture
can
means
go to the next
it'll.
page.
Oh. So that means it'll work even without the catalyst, but it'll take a longer time. That's it.
exactly, yeah. We are using catalyst in order to increase the rate of reaction. So that means you can use zinc either as a catalyst or you can use chromium oxide as a catalyst. Now, okay, let's see the next one. Next is actually the reaction with alkenes. That is actually the hydrogenation. Hydrogenation means addition of hydrogen, right?
Yes, sir. The reaction with alkaline metals, alkyne.
Alkenes. We are having CH2 double bond CH2. This is your alkene, that is ethene, right?
Yes, sir. So
And
what is
if
the
you
spelling
just
of alkene?
it is Alkene, alkene. When it reacts with hydrogen, so what will be the product? Alkane will be formed, right? That is CH3 bond CH. This is your ethane, ethane, and this is alkane, Jane. Now, this hydrogenation it is very important in the what we can say that is the preparation of oil, right? By having
Konguel mute.
Oh, your voice is breaking, sir.
No, Konguel's voice is
No,
overlapping.
there's no like we're not speaking. There's no background noise also.
There's a
Bruh.
car noise from you, like some air blowing noise from
What?
I
your side.
know. Yes,
Yeah.
there's a
yeah,
lot of background noise.
there is some background noise. So, okay, let me continue. So, oil, when it is actually treated with hydrogen gas, this is the hydrogenation of oils. So, here we use the catalyst nickel. And what we get the fat. This reaction is very important. It is used for the synthesis of, for the preparation
What
of,
oil is used?
Fat.
you can, okay, you can use the
Oil,
vegetable oil. Vegetable oil.
fat
When
oil.
we, yeah, when we take the vegetable oil, when it is hydrogenated, we get the fat. And with this reaction, what we can prepare, we can manufacture vanaspati fat or vanaspati ghee.
Is this also hydrogenation?
Yeah, exactly. This is the hydrogenation. So that means actually what you have to remember here, that is vegetable
But
oil. It is your
hydrogenation is changed from alkene to alkane, right?
hydrogenation means addition of hydrogen. Hydrogenation simply means addition of hydrogen.
That means every
Okay.
single reaction we learned so far is hydrogenation.
Hydrogenation means addition of hydrogen. Whether you add this hydrogen to the alkene, whether you add to this oil here, both are the hydrogenation reactions. So this oil is actually your unsaturated. Can you tell me what is unsaturated?
So when it absorbs, I mean, no, it can absorb more
Yeah, more solute, more
water
solute.
crystallization molecules.
No, no, no.
No, sir.
That is actually what you study in the solution. But here in organic chemistry, unsaturated
Normal
means
like unsaturated oil, like
that
it'll be written in the packet also. Unsaturated
Yeah,
oil.
unsaturated
but
in
you'll
organic
study
chemistry
next time.
means that it will contain carbon double bond here.
So
Okay, you
like
will
in
remember.
some ghee
Oh,
packets and all,
oh,
it'll be written
Vanarpati ghee is a
unsaturated fat,
company
right?
name. I thought Vanarpati ghee
No
is
da.
some. Wait,
Vanaspati ghee means like it's called dalda in like common terms.
Exactly,
It,
what?
vanaspati ghee. That means which
it's
is
called
actually
dalda.
saturated. Saturated. This is your saturated fat. Have you got it? Vanaspati ghee is saturated
They
fat.
use it in like restaurants and all. It's has
Yeah,
more
exactly. It is
calories.
used. Yeah, exactly. It is used in every kitchen. We are using this Vanaspati ghee. So see, unsaturated organic compounds are actually those which contain carbon-carbon double bond or carbon-carbon triple bond.
unsaturated is not fit for us to use normal in food,
No,
sir.
we can use.
We can use.
Yeah.
Vegetable oil is unsaturated, right? That's what we use for cooking.
I use
Yeah,
different ones.
it depends if there is a fatty person having very lot of saturated fats, so then it is advised not to take these ones. Is the screen visible?
Yes, sir.
Sir.
Yes,
Sir.
sir. Uh-huh.
Okay.
Yes, sir.
So what you have now remembered, what is unsaturated organic compound?
Sir, double bond.
Or it should contain carbon-carbon triple bond, right?
Yes, sir. So how, sir? Carbon has four. That means it needs a two lone pairs, right, sir?
How does it go three?
Yeah,
Sir?
it needs two lone
Just
pairs, right, sir.
okay, I will tell you. For example, in this above one, ethene, there is carbon-carbon double bond. Is it there? Can you see it?
Yes,
Yes.
sir.
Yes, sir.
Okay. Now, in case of alkynes, there is carbon-carbon triple bond. Do you remember what is an alkyne?
Yes. No.
What is an alkyne?
No, I don't
Alkyne is
know.
an organic compound which contains carbon-carbon triple bond. For example, I will give you the example. Example is your ethine, that is CH triple bond CH. This alkyne is known as ethine. Got it now?
Yes, sir. Eat ein.
Yeah, it is known as ethine. See, this one was ethene. Can you just have a look here? It is
Yes, sir.
ethene,
Ethene,
and this one
ethane,
was
ethine.
ethane, and this one is ethine.
Sir.
Yes, sir.
Yeah, you had to remember these three. One is your ethane, ethene, and ethine. So, can you tell me
Alkene, alkane, alkyne. Like that.
exactly alkane, alkene, and alkyne? So, can you tell me what are saturated organic compounds?
Sir, oh,
Four bond or something like that. Single bond.
Those organic compounds which contain carbon-carbon single bond in them
Oh, I was
only.
right.
oh,
Yeah, I was right.
Example will be the alkanes, right?
you were close. You didn't
I
say
said four
carbon.
bond and then I said
You said
single
yes,
bond.
yes. You didn't say carbon.
I said
Yeah.
carbon single bond.
There must be carbon-carbon single bond only. If there
Oh.
is double or triple bond anywhere, then it is your unsaturated, right?
So single bond is saturated.
Exactly.
Sir,
Single
but
bond
I
is
don't
always double.
understand about single bonds. So that means there'll be like three lone atoms that
See,
they
Lone
can't
pairs.
found.
single bond, I have given here the example. This one example. Can you see this alkane here, ethane? There is
Yes, sir.
carbon-carbon single bond.
There'll be three lone pairs in that case.
Three lone pairs.
No,
What will be three
no,
atoms?
no. There will not be any three lone pairs. See, actually, can you tell me how many valence electrons carbon has?
Four.
Exactly. One,
Four,
Yes.
sir.
2, 3,
Four
and 4.
lone
Correct?
pairs.
There's no
Correct?
pair. Yes, sir.
Correct? Okay, now
Yes.
tell me next carbon. Next carbon is
And
there.
four. Four.
It has
Four.
also the so 1, 2, 3, and 4, right?
One and one
Yes, sir.
bonds.
Okay, now tell me they will form just single bond between them, and another bond will be formed with the hydrogen atom. So this one is your one hydrogen here.
One pair is there. One lone pair. I mean two lone
There
pairs.
isn't any lone pair. There isn't any lone pair
Oh, there
on the
is
carbon.
three. Oh, there is three.
Oh, okay. It goes on like a cycle,
Oh, so
like a chain.
hydrogen, I mean carbon cannot have a single bond alone without any other.
It's like a chain.
Yeah,
Yeah,
without
there
hydrogen
are
it can't form.
hydrogen atoms. There are hydrogen atoms which actually complete its valency. Carbon is always tetracovalent, right?
So without
Forms
these hydrogen atoms, they can't form a single bond.
double bond. Exactly. Hydrogen cannot form double bond. It has only one
Sir,
electron, so it
triple
can form.
bond or triple bond means three electrons fusing with other three electrons in the carbon.
Transferring.
Exactly,
Yeah.
exactly. Okay, okay, I will,
Okay.
I will tell you. For example, this one. This one is your ethine. I will draw the structure of this ethine. How many valence electron it has?
The ethine is two, no three.
Carbon has 4 valence electron, right?
Okay.
Hi, for yes, five, sir.
No, four there.
Carbon
Just
has
two
4
is
valence electrons. So among these 4, it shares the 3 electrons in order to form 3
carbon, one
bonds.
more
Triple
atom.
bond.
Yeah.
Yeah, then it forms one bond with the hydrogen atom.
Yes, sir.
Yes, sir.
Exactly. This is the structure of ethine.
Yes, sir.
Is it now clear?
Yes, sir.
Yes, sir.
Shall I
The
move to the next
carbon
page?
can form a double bond without any other element,
No,
right?
no, there should be hydrogen also. For example, in case of this ethene, there is carbon-carbon double bond, but there are also the hydrogen atoms. It can
Oh,
also form double bond with oxygen. It can also form double bond with oxygen because oxygen is divalent.
yes, sir.
So just note down this.
Yes, sir. This is, I think, this is the last chapter we're gonna learn for second term, sir.
Yeah, today we will
I,
complete this.
we don't even think we'll finish this chapter.
Yeah,
So
we
we
won't even.
still
I think like the periodic table is the last chapter we will have for second term, sir.
maybe.
Yeah.
Probably.
Today we are also going
Depending
to
on our.
complete this one chapter, that is the hydrogen.
Yes, sir.
Yeah. So shall I move to the next
Yes, sir.
page?
Sir, should we draw ethane structure?
Yeah, exactly. If you draw, then you can remember that how actually these bonds are formed, how carbon shares its four valence electrons, and how hydrogen forms here the bond. You can draw the structure of this ethane and ethene and ethine. These are very simple structures. You can try them so that it will become very easy when you go ahead. Have you drawn these structures?
I am drawing, sir. I didn't know.
Okay, you just draw it. So you have to remember that if there is carbon-carbon single bond in any organic compound, then it will be saturated. And if there is any carbon-carbon double or triple bond in any organic compound, then that will be unsaturated, right?
Sir.
Yes, sir. Sir, so in hydrogenation, there's always
Addition of hydrogen.
unsaturated to saturated.
Exactly. Whenever you do the hydrogenation, you should first have unsaturated compound. Then when you just do the hydrogenation, then the product will be your saturated. Exactly.
Yes, sir.
Shall I move to the next page?
Yes, sir.
So next, what you will learn here, that is actually a very important term that is called occlusion. Have you heard this term occlusion?
No, sir.
Okay, then just remember this. Occlusion is actually, it is the adsorption of gas by some metals. Absorption of gas by some metals. That means there are some metals which actually adds this hydrogen gas. So adsorption of gas by some metal, that's called occlusion. For example, hydrogen gas gets absorbed. It gets absorbed on the surface of nickel, palladium, platinum, right? So they act as your such
Fusion.
substances which, yeah, this phenomena is known as occlusion. So that means the hydrogen gas, it gets easily adsorbed on the surface of nickel, palladium, platinum. Got it?
Sir, is it
Yes,
absorb or
sir.
adsorb?
It is
Absorb.
adsorb. Yeah, this is difference. So can anybody tell me what is the difference between absorption and adsorption? I will write it here. One is absorption, right?
Yes, sir.
Another is adsorption. See, actually, what is the difference between the two? If you just look on this one, that is your absorption, it is a bulk phenomena. Can anybody tell me what is this bulk phenomena?
Like it absorbs in bulk.
Yeah,
Bulk means
bulges.
like large amounts.
Actually, it means
No, means
actually that it absorbs in the whole body within it, right?
Like a
And
sponge.
this adsorption, it is a surface phenomena. That means it actually only occurs on the surface. Got it?
Where will it get absorbed, sir? Like on the surface, and then after it gets absorbed, where will it go, sir? Like remain on the surface?
Yeah, exactly. It remains only, it is absorbed only on the surface. There is l- some few particles can enter into the bulk, but most of the particles, molecules, they remain at the surface. So that's why it's known as adsorption. It's a surface phenomena. So that means here in this, for example, if you have to just represent bulk phenomena, for example, this is the substance, and let's say the other particles, they have just got inside this. So this is the bulk
Absorb.
phenomena. This is the absorption, yeah. And now if most of the particles, they are just absorbed only at the surface, then it's called the adsorption, right? Few may enter, but most of the molecules will be at the surface. Got it?
Yes, sir.
Yeah, then we will see what are the uses of this hydrogen. So why this hydrogen gas is used?
Uh,
so like for burning and combustion. For burning and combustion, it's used. For car
Exactly.
fuel, it's used.
So hydrogen is used as a rocket fuel, right? It is used as a rocket fuel because
I
it
thought it
has
was
pro,
nitrogen, sir.
no, it's not.
Nitrogen doesn't burn, bro.
nitrogen is inert gas. How can
Puts
that
off
burn?
fire.
Yeah,
Hydrogen burners, it has highest calorific value, so that's why it's used as a rocket fuel.
so they
Highest
use
calor.
Oh,
ferrofluid.
sorry, it's liquid hydrogen, right? I thought it was
Yeah,
liquid
exactly.
nitrogen.
Highest calorific value.
Thought they use
Sorry.
ferrofluid for rockets.
Liquid nitrogen is
Bruh.
different.
Liquid nitrogen is acting as an inert gas that will not burn. So can
Yes,
you
sir.
tell?
I switched it
Okay,
up.
okay.
Eh, just
No
admit it
problem.
once in a lifetime.
Exactly. I have got
Actually,
your-
Admit
I
it
forgot.
once.
Okay.
I thought they
Now,
used ferrofluid, sir.
which one?
Hey, we don't talk about
Ferrofluid.
NASA, da.
The black. Okay. Yes.
Hydrogen is used as a rocket fuel. You will remember this. So
Highest.
next is
What's that written, sir? Highest.
hydrogen is highest
Highest
calorific
calorific
value.
value.
Yes.
Calorific value. So
Yes,
it is
Will
sir.
used as
burn the fastest.
yeah for space research, right? Liquid hydrogen we can use and liquid oxygen. We actually use here. If you remember a little more, then you can remember that we use the liquid hydrogen and liquid oxygen.
They help in burning.
Exactly. Oxygen is always the supporter of combustion.
Without
So now
oxygen,
tell
it won't
me,
burn.
yeah, next is that if we just talk of the use of hydrogen, as I told that it is used in the manufacture of vanaspati ghee, isn't it?
Yes, sir.
Yes, sir.
Yes,
So
sir.
you can write it here that manufacture of vanaspati ghee. Next, you can remember that we can also manufacture ammonia. That is a very important industrial process known as Haber's
Haber's
process, right?
process.
Exactly.
So what can we do with ammonia, sir? You can make
Exactly.
fertilizers, right?
This is very important. That what we can do with this ammonia, we can make various fertilizers. So can you
So
name
apart
any
from that, what can
fertilizers
Pesticide.
are very important for the fertility to increase the fertility of soil. We are using these fertilizers to increase the
Hey,
yield
how
of
can they use something for both fertilizers and pesticides, bro? It's like the
Bruh.
opposite.
I'm stupid, bro. Don't question.
pest. Pesticides are actually used to kill the harmful pests, and fertilizers are the substances which increase the fertility of the soil. Both are different. They are
Yes,
not
sir.
same. Yeah.
I know phosphorus is also used.
Nitrogen is
Yeah,
also used.
yeah, they are actually the nutrients, phosphorus, sulfur, nitrogen. They are the
Potassium.
yeah, potassium. They are the
The
actually minerals.
platinum.
What?
Platinum.
Yeah, I heard it somewhere that platinum is also used in
So can
Maybe
you
that's
tell
some
me?
chemicals.
new kind.
Only
Can
if
you tell?
Ambani owned the farm.
Oh,
So
actually, it's true.
Yes, sir.
I said
have you
flying
noted down?
spiders exist. You guys didn't exist.
Shall I move to the next
Yes,
page?
sir.
Yes,
One second,
sir.
I'm in the last one.
Okay.
I also said flying spiders exist. You guys didn't believe me.
Yes, sir. You can go to the next page.
So can you name few fertilizers from this ammonia which we can form from ammonia? For example, you are having
There's names
ammonium.
for it.
Yeah, fertilizers which we prepare from this ammonia, that is ammonium
I don't
sulfate,
know,
right?
sir. Oh,
Ammonium chloride.
oh my, we didn't learn that they are called fertilizers, sir.
Yeah, ammonium sulfate, ammonium phosphate. We can have various fertilizers which we can prepare from this ammonia. Ammonium,
Nitrification, rhizosphere by core, methane.
etc.
So we can
So we
also
can
get methane from nitrogen. I mean ammonia, ammonium.
ammonium sulfate, you can have ammonium chloride, ammonium phosphate, ammonium nitrate. Yeah, exactly.
Methane, right, sir? Methane is also.
Methane is known as marsh gas. That is not the fertilizer.
Oh,
Yeah,
Methane is like toxic. It is toxic, right,
methane
sir?
methane is
but
a gas,
all
marsh
different also.
gas. Okay, I will tell you why methane actually causes the greenhouse effect. Do you remember that?
Yeah, it's toxic.
Yes,
Yeah,
sir.
Yes, sir.
like traps in
Exactly.
all the carbon dioxide, heat, and
It
everything.
traps the sunlight, exactly. So it warms the surface of
Earth.
Earth. So that's called the greenhouse effect, which causes finally the global warming, right?
Yes, sir.
Yes, sir.
Okay.
I'm
So can you
happy
tell
to
me
know.
the next use of this dihydrogen, where it is used?
Um,
Use it in the preparation
Mm,
of metal hydrides, right?
so I thought we already studied that.
We have studied that. Yeah, exactly. Preparation
Yeah.
of metal hydrides.
but it's like finally like the advantages and uses.
Okay.
What
Metal
is useful
hydride.
for preparation of metal hydrates?
Yeah, metal hydride is
Hydrogen.
there. Yeah, for
Okay,
example,
okay.
if we are having these metal hydrides, they can just be used as interstitial compounds. They can be just used as conductors. So this is the use. Similarly, we can also prepare the alcohol, that is methanol, right? That is CH3OH. We have seen this
Uh-huh.
from water gas, right?
Yes, sir.
And this methanol, it can be used as a synthetic petrol fuel, right? Another use you can remember, that is we can also make atomic hydrogen torch. Atomic
Oh yeah,
hydrogen
so it's
torch.
called spirit lamp, right? No,
So can
No.
you tell me for what purposes we can use these and oxy
sir, it's
hydrogen
called
torch?
spirit lamp, right?
They are used for cutting
More
and welding
brighter.
purposes. Cutting and
What?
welding purpose. Cutting and
Oh
welding
yeah,
purpose.
the
That
like
thing you
it's
put
very
you put
hot.
black glasses so your eyes won't get hurt. That one.
Yeah, yeah, yeah.
Oh, that
Exactly.
one.
Very bright, like
Yeah, for cutting,
welding
when you
machine.
cut, yeah, when you just weld for welding of chain, for cutting of iron, right?
So
Yes,
Exactly.
sir.
For cutting and welding purpose. So this is the use of this dihydrogen, right?
yeah.
It's also used in fuel cells, right, for generating electricity. Also used in, yeah, it's
Yes, sir.
used in fuel cells. And what we do in fuel cells?
So electricity.
Yeah, for generation of electricity. Electric current we can generate in this fuel cell.
So
And
is
these
there
fuel
any use for the light property of hydrogen, sir?
light property.
Like it is lightest gas.
Yeah, it is the lightest known gas. That's why it's
Is
used.
there use for
We,
it being lightest gas? Like, do they any
it is the lightest known gas.
and
So
do they use it for anything?
we can use it in balloons, but it is always preferred to use helium because hydrogen is a gas and it can burn, but helium is inert, right?
Will burn.
Yeah,
It'll
actually
explode.
it is fuel, so it can explode, it can burn, and it's having very high calorific value. That's why we don't prefer to use this hydrogen in balloons, but we just prefer the helium, which is inert gas.
Yes,
Getting?
sir.
Exactly. Now, this was regarding the uses of this hydrogen. Now, there are few questions which are important here. First, tell me, is the screen visible?
Yes,
Sir.
sir.
Yes, sir.
It's stuck,
Okay.
but it's visible.
So why do you get that doubt, sir?
Which
Hello?
doubt?
From your
Hello?
Yes.
Hello?
yeah, da, we can
Yes,
hear you. Da.
uncle.
Yes, Sankar. Are you having any question? Can you hear
No, sir.
me?
He don't. He doesn't have
Sangal.
it.
Can you hear me? Sankar, can you hear me? Can you hear me? Is my voice audible?
Yes, sir. We
Jungle.
can hear you, sir.
Okay. So now there is a term that is
I'll rejoin, sir.
okay,
If
okay, you can rejoin. Sodium amalgam. Can anybody tell me what is sodium amalgam?
So we had this question, thing, sir. I didn't know what it was.
I forgot, sir.
Sodium amalgam, it simply means when you just put sodium in mercury.
Oh,
Oh, yeah,
So
I
it is,
remember.
yeah, amalgam is
amalgam means
actually,
mercury, then.
yeah, amalgam is actually an alloy containing mercury. So you will write this
Hello?
amalgam. Yes, I
Yes,
can hear you.
uncle.
Yes, sir, I can hear you now.
Okay, okay. So amalgam is an alloy containing one of the metal mercury, containing mercury. That is Hg. Got it? This?
Yes, sir.
Yes. Sir.
Yeah. So you will. Can you tell me that why we just keep this sodium in mercury? Why not in water? Can we store sodium in water?
Sodium
Because it'll
is reacting
explode,
to
sir.
water, sir. It'll explode.
Exactly.
To
Don't be
Sodium,
lazy.
sodium is highly reactive. It explodes when put in water. There is very high exothermic reaction, and reaction is very vigorous. And the hydrogen released, it catches fire. So that's why it's
Sir, I
always
thought it
kept.
was only potassium, sir.
Whoa,
nope.
whoa, whoa.
That
How did
no.
you not know this?
Sodium,
Something's like a just
sodium
salt,
cannot
sir.
be okay, I will write it here that sodium cannot be stored in water. It can be stored in kerosene
Sir,
or mercury.
potassium also reacts like that, right?
Exactly. Potassium will also react, but sodium
Most of the
reacts.
first few
Yes,
elements in the reactivity table do it.
cannot be stored in water. So where it is stored then?
Kerosene,
Yes,
mercury.
Exactly. Exactly. It is stored in kerosene. Kerosene oil. Have you noted down this?
Yes, sir.
Shall I move to the next page?
Yes, sir, 1 second, sir.
Yes, sir. Okay, 1 second, Sangal.
So what's the chemical formula for kerosene?
Kerosene, it actually contains
Stop
a lot
that.
of hydrocarbons.
Bro
There
is
isn't
doing
any
Yes,
single.
sir.
ASMR eating.
Oh, so do they have a single bond or
I'm not eating.
Yeah, single bond.
Done,
oh, in
sir.
the textbook? So it's given as C12H26 single bond, C15H32.
Yeah, that's the hydrocarbon, exactly.
Dude, why do you sound like every
Yes, sir.
ASMR guy?
Now see here another. Okay, there is question that tell me if I am having calcium and I am just putting it in water, right?
Yes, sir.
Yes, sir.
Now there is formation. There is effervescence. Can you tell me what is this effervescence?
So when the
Uh,
water of crystallization, no, that I'm, oh,
That's it. Effervescence.
effervescence. I don't know what that means.
Effervescence means that there is some gas is released inside the solution, right? Effervescence. Bubbles are coming out. I will write it here.
so the
Bubbles.
process in which when salt is exposed to air and loses its water crystallization.
No, that's efflorescent.
Bubbles are
That's what
coming
he
out.
asked. Yeah.
No, he says effervescence, sir.
Yeah, it is
Effervescent.
effervescent.
Ah.
Now, so can you tell me the reaction? Okay, can you tell me the reaction and which gas will be released here?
Hydrogen.
Exactly, it will be hydrogen. So what will be the complete reaction?
The calcium plus water gives calcium
Hmm.
hydride. No, calcium oxide plus hydrogen.
No, calcium hydroxide will be the product, and this is the white PPT, white precipitate,
Yes, sir.
white PPT, and we will also get the hydrogen gas. So can you balance this?
Sir, 2H2O.
2H2,
Oh,
right? Okay, then there is question for you that how can you test this hydrogen gas? What is the test for hydrogen gas?
so
How
like put
you
it under water and it'll bubble out, and then you can.
Yeah.
Is that what?
That is any gas.
Yeah, that is if there is any gas, there will be bubbles. You have to just tell me how you can detect this hydrogen. Test for hydrogen.
Sir,
Sir,
you have to put the hydrogen in water so to see if it
I
actually
just
like
that.
mix like combines with the water. If it combines, it's not hydrogen.
No, there are a lot of
Gases
gases which
does
will
not.
not combine with
Yeah,
the hydrogen.
like so many
so
gases.
you burn it in
No,
front.
it's like only the first, bro. If you burn
Very
it
good.
and
It is
it actually burn, sir,
Oh,
but
You
if you
see,
burn it and it, sir, but if you burn it and it
oh.
actually burns, the
just
entire H2O is wasted, right, sir?
okay, now see here, when you just burn this hydrogen, it always burns with pop sound. So when there is pop sound, it clearly indicates that this is the hydrogen.
learned it in Sanskrit, sir. I remember.
Exactly. So this is very important to remember the test for hydrogen. So it is the only hydrogen gas which when burns, it produces pop sound. It burns with pop sound.
But there's
So
so
next is now next very important. Now if you are having this mixture that is calcium hydroxide and hydrogen, what will be the test? What will be the color change if I just put litmus paper
what?
in this mixture?
Sir,
When the
turn red, sir.
why it will turn red?
What
What is the reason?
mixture?
No, sir, it'll turn
No, the
dirty
litmus
green.
paper will turn the paper
Oh,
will
that
turn red.
Oh, it's
that
that
okay, that
testing
one.
thing,
Yeah, it's that one. It's that one. You
See,
remember?
see,
I
I'm
don't know.
again repeating that I'm having calcium hydroxide, right? Calcium hydroxide, and I'm having hydrogen gas in it. This is the mixture, and I'm just putting litmus paper in it.
Yes, sir.
So, can you tell me what will be the color change here?
Sir, it will change
It'll
shape,
turn red.
sir. Yes, sir.
See,
It
it was
will turn
white.
red.
It was white PPT, right? It was white PPT. Now
Sir, it'll turn green.
I'm just putting red
Bro,
litmus
there's
paper
no
in
green color in that paper, guys. It's
red
only red
litmus
and
paper.
blue.
So it will just get converted to which color?
Green.
Red, sir.
Blue.
Exactly. It will just turn into blue color.
How?
Because you
Okay, I will tell you how. Because this mixture
Yeah,
is base.
both.
Calcium hydroxide is what? Is it acid or base?
It's
base.
Sir, it's a
It is
base,
base.
sir.
Base, I
Exactly.
mean
It's a
When
base.
you
Yeah,
just
yeah.
hydroxide, so it's
have
basically a base.
base,
oh yeah.
it
The
will
base.
change red litmus paper to blue. This is very, very important.
Oh okay. My bad.
If you are having any acidic solution and you put just the blue litmus paper, then it will turn
It'll
it
turn
into
red.
red. Exactly. Got it now?
Yes,
Yes,
sir.
sir.
So this reaction will be important. Next, shall I move to the next page?
Mm-hmm.
Yes, sir. Yes.
Yes, sir.
Okay. So I'm having the three metals, that is magnesium, iron, and copper, right?
Yes, sir.
Tell me the which will be more reactive towards oxygen.
What did you ask, sir?
I'm
Sure,
again
yeah.
repeating that if I'm
Okay.
having the three metals, that is magnesium, iron, and copper,
So
which
it will like
among these
easily
will be
magnesium.
more reactive? Which is
Magnesium.
more reactive towards oxygen?
Magnesium.
More reactive towards oxygen.
Magnesium, sir. I think.
Magnesium or iron.
Or
No, you
copper.
have to tell me only one option. You have to tell me only one
Magnesium,
option.
sir. Magnesium.
Magnesium, sir.
Exactly, its answer will be
See,
magnesium because
I was
Hey,
magnesium is
let's go.
If I just write the order of reactivity, do you remember the order of reactivity?
Yes,
Reactivity
Yes, sir.
is simple.
Potassium, sodium, calcium,
Exactly.
magnesium.
Exactly. So that means magnesium is more reactive than iron, and iron is more reactive than copper.
yes, sir.
Okay. Now tell me that if they react with oxygen, what will be the product format?
Oxide.
Sir, magnesium
Metal
oxide.
oxide. Metal
Metal
oxide.
oxide. Metal
Exactly.
oxide.
So can
I'm
you
so smart.
complete these reactions?
The MgO.
MgO.
FeO.
MgO.
No, maybe.
Okay, MgO. Can you balance it?
Yes, sir. 2 mg plus
2
O2 gives 2
mg and
MgO.
2
2
MgO.
MgO.
You have to
Okay,
give 2
2 mg.
mg also. 2 mg also.
I know, that's what he said.
That's what he said.
Next, can you balance the next one?
So
Yes, sir.
2 Fe plus
4
3.
Fe plus no,
2F.
Sir,
it's
2
4
Fe
Fe
and
plus
3
3.
O2. 3 O2. 3 O2 plus 2 Fe. So, yeah,
It's wrong. It's 4 Fe.
Yeah,
Exactly,
it's,
it
Why
will
you
be
said
sorry,
4F.
it
it's,
so?
it's 4 Fe.
4
Why
Fe
Fe
said
and 4
it?
plus
Fe.
3 O2
3
gives
O2
Exactly.
gives
2
2
Fe2O3.
2O3.
Yeah, 2 times Fe2O3.
So let the kids answer.
Okay, now if you are having copper, it reacts with oxygen, copper oxide, that is CuO. Can you balance it?
CO, sir.
So it's so easy,
So
C,
sir.
2
2
Cu
CO
plus
and 2
O2
O.
gives 2 CO.
Exactly.
Yes, sir.
Now, can you tell me that if these three metals they are just treated with dilute hydrochloric acid, what will be the product?
So, what is treated?
Magnesium
Dilute
chloride plus
hydrochloric
hydrogen.
oxide.
On reaction with dilute
Hydrogen.
hydrochloric
No,
acid, HCl.
hydrochloric acid. What do you expect?
Sir, it's Mg plus HCl.
Okay, yeah,
Oh,
exactly.
is it
Tell me
that?
the reaction.
No,
Oh
is
my
it that
god.
reaction? Is it that reaction?
No.
Yeah.
I'm asking.
Well, give MgCl plus H2.
It will give
MgCl plus H2.
MgCl2, magnesium chloride plus
Oh,
H2.
it's
Oh yeah.
chloride
Oh yeah. Right.
plus H.
MgCl2 plus H2.
So you can balance it by writing twice here, twice.
Yes, sir.
Twice.
Okay, now tell me that if I'm just reacting iron, what will the product be same?
That is so easy, sir. Like
Uh,
FeCl3. FeCl3 plus H2.
FeCl2 plus H2, right?
bro.
What Cl2, sir?
It's
Hey,
Last
it's
2
time
and
you
not.
used
3 say
ferric, now we're using ferrous. What is this, sir?
This is the ferrous chloride. Here it is the
Why
ferrous
do you use
chloride.
ferric oxide, sir? There at the top.
Which one? Yeah, this one is the ferric oxide. It depends actually the axis. If oxygen is in axis, then you will get the ferric oxide. Similarly, if hydrochloric acid it is in axis, then you will get the ferric chloride. It depends on the quantity.
There's
Sir, but in that
hydrogen. There
case,
is.
like iron is in excess, right? Oxygen is lesser, right?
See,
That's what you
if
want.
I am saying here that if iron is in excess and HCl is not in excess, it is in minimum amount, then it will be ferrous chloride, that is FeCl2.
Yes, sir.
But if HCl is in excess, then it will be ferric chloride. Now tell me the next one, that is Cu. It reacts with dilute HCl. What will be the product?
Same thing. So Cu plus
Plus
CuCl plus H2.
Sir, CuCl2 plus
CuCl2
H2.
CuCl2
plus
plus
H2.
H2.
This is
And
very important. There
2HCl.
will
That's
be
it.
no reaction.
Oh,
There will be
yeah,
no.
right. Oh, hydrogen. Oh, copper is less than hydrogen.
Oh,
Oh,
This is very important. Copper is less reactive than HCl, so no reaction. It will not react.
so you really caught us off guard, right?
Yeah. So have you
copper
noted down?
chloride.
We're caught lacking.
Yes, sir. Done, sir.
Shall I move to the next page?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now these are the same metals, and the question is for you that if I am just treating them with zinc sulfate, third question is that on reaction with zinc sulfate, what will be the product format?
With what, sir?
Zinc
Hydrogen or
Zinc
sulfate.
oxygen?
sulfate.
Oh,
You're having
magnesium
the
zinc
same
sulfate
metals,
like
that
that.
is
Sir, it
magnesium,
is. Sir, it is MgSO4 plus
magnesium,
Zn.
iron, and copper.
Sir, it is
I'll do copper. I'll do copper.
MgSO4 plus Zn, sir.
Okay, I will write it here. You have to also balance side by side.
Will do iron. Congo will do iron. I'll do copper.
Okay, now
It's
tell me.
not possible, duh.
Oh yeah,
Now,
yeah, that's right. I'll do copper.
so it will be your
I'll do
magnesium
copper.
sulfate, right?
Yes, sir.
Yes, sir.
And what will be the
Plus
byproduct?
Zn. Sorry, plus yeah,
Byproduct will
plus
be
Zn.
magnesium sulfate plus zinc.
Zinc. Okay, is it balanced?
Yes.
Yes, sir.
Okay, tell me the product in the next one reaction.
Sir, not possible,
FeSO4
sir.
thrice. No, I don't know. Fe2SO4.
Ha!
Hey.
See, I
Because
told you.
Not
iron is
possible.
less
So next
reactive
one
than
also.
zinc. Iron is less reactive than zinc, right? Zinc is
Yes,
more
sir.
reactive.
Yes, sir.
Yeah.
And
Okay.
zinc
What
is
will be
more
the product
reactive.
in the reaction, third one reaction?
Not possible. Not possible.
Not feasible.
Exactly. It is not feasible because copper is less reactive than zinc, right?
Yes, sir.
Sir.
Yes, sir.
Because of technical issues.
Yeah. Okay.
Stand by this.
And now tell me, sometimes question is asked that there are some unique metals like we are having aluminum is there, like zinc is there. So can you tell me how they are unique?
Because they.
If you have just studied the preparation of dihydrogen, I have just told you the reaction from alkalis. Do you remember that reaction?
I don't.
No, sir.
1 second, sir. I'll just check. Sir. I'll check. I would have written it down.
You just check out the preparation from alkalis. I have studied this. We have
Yeah,
studied this.
sir. Zinc plus sodium hydroxide.
Exactly. So you have to actually remember that this zinc and aluminum, zinc oxide and aluminum oxide, they are amphoteric in nature, right? You have to remember this. Aluminum oxide and zinc oxide, they are amphoteric oxides. Can you tell me what are amphoteric oxides?
I don't know. I don't,
Amphoteric oxides. Amphoteric means having both acidic as well as basic properties.
basic in a sense basis like that basic
Acidic as well as basic. Yeah, acid as well as base.
uh, basic possible
That means they can react with both acid as well as
base.
base. So that's why they
Yes.
are amphoteric. You have to remember this. They are amphoteric. Got it?
So
Yes, sir.
Yeah, just note it down.
1 second, sir. Finish, sir.
Okay, now tell me here if I just write here that I'm having NaH, that is your sodium hydride, right?
Yes, sir.
And I'm reacting it with water. Can you tell me the product?
So uh, sodium hydroxide
Okay,
plus hydrogen.
very good. Sodium hydroxide.
Oh yes, I understood it, sir. I think
Okay, can you balance it?
yes, sir. It's already not balanced. It's already balanced, sir.
Exactly, it's already balanced.
Yes, sir.
Yes, yes, sir.
So if I just give you this one reaction, that is magnesium nitride plus water, can you tell me the product?
It is
Magnesium nitrate, nitrite.
No, it will be magnesium hydroxide.
hydroxide.
Oh, totally wrong.
And next will be what?
Nitrite.
Next byproduct? No, it will be ammonia. Very important.
So what? Wow. Okay.
Can you balance it?
Okay, sir.
Um.
H3, 2, 2, 3.
Just try to balance it. Have you tried it?
Some
Balance
kind
it?
of
Okay.
um.
there are 3 magnesiums, right? Magnesium
So
atoms.
3 MgOH twice.
Yes, sir. You.
Then trial method I'll try, sir. Mg3, that means here also I'll put 3 MgOH twice. And then here H is 2 and there it is 5 plus 3, 8. So I'll put 4 here. That doesn't work. So what is this? Why can't I?
Has anybody tried?
I'm trying, sir. Oh wait. Oh yeah, okay. 1 second, sir. I'm almost done.
See, it is there 3 magnesium atoms are there, so I will write here the 3. Now there are 2
Yes, I
nitrogen
got it,
atoms
sir.
here.
I got
I
it.
will write here 2.
6
Okay, tell me.
H2O.
How many times H2?
6.
6.
Exactly.
Sir.
Yeah, it is now balanced, right?
Yeah.
Yes, sir.
Yeah.
Okay, now there is also very important reaction that if we are having this carbon, you can just call it as coke, and you are just reacting it with hydrogen. But what are the conditions here? We are just having very high temperature, that is 2775 Kelvin. This is very high temperature, right?
That's
And
very
we are just passing the electric spark. Can anybody tell me what will be the product here?
I mean,
Sir,
Yeah,
it
that
burns so quick, so
there is
not
actually formation.
flammable.
Okay, I will tell you. There is formation of alkyne. So can you tell me which alkyne will be formed?
Ca- e- uh, Ethine.
C. Yeah, exactly. It is ethine. That is C2H2. Ethine will be formed. So can you balance it twice?
So 2C.
Yeah, exactly. It will be 2C and plus H2. So it will just give you C2H2.
The
Ethine.
spark in the sense, how do you do it, sir?
Yes.
like
How do
you
you?
have lighter in your house, right? So like even that
And
Oh,
creates
that's a
spark.
spark, right?
that's actually a very small amount of current without any.
Okay, sir. So then, how do you put heat and spark at the same time, sir?
Why
Yeah,
not?
we can. Why
Or
not? It
just
is
heat it while sparking? Oh,
Spark is like it's not even a big
actually
deal to make.
actually the apparatus in which we are just reacting this hydrogen with the coke, that is already kept at a temperature of
or
2775
just to
Kelvin.
take it out, put spark on it, and just convert it like that.
Exactly. Then we are just electric spark.
I don't want to hear you.
Yeah, because you don't want to improve yourself.
I got more marks than you.
So have you noted down this?
Yes,
Yes,
sir.
sir.
So with this, we have just completed this whole chapter. If there is any question, any doubt, you can ask.
No
No,
doubts,
sir.
sir.
If you have any question, so you can ask regarding the isotopes of hydrogen, regarding the
No,
position
sir.
of hydrogen.
So,
So I have a question, sir.
Okay, tell me.
So you asked one question, what's the position of hydrogen?
What is the?
One question. I'll just take that question, sir.
Okay.
The last question, you asked what's the position of hydrogen with respect to its electronic configuration? You asked that question.
Yeah, position of hydrogen. We have already discussed it in detail. Position of
So
hydrogen.
with the help of electronic configuration.
Electronic configuration. I told that hydrogen, its atomic number is 1, so its electronic configuration is 1. So that means it has only one electron in the valence shell. So when it has only one electron in the valence shell, it can just resemble with the alkali metals. For example, lithium, atomic number 3. It
It
has
can also
also only
resemble halogens, right?
Okay, I will tell also with the halogens. For example, first with the alkali metals, so it is 2 comma 8 comma 1. So all these have one electron in the outermost shell, so they have same electronic configuration. But if we just look with the halogens, halogen is fluorine, chlorine, bromine. So these have 7 valence electrons in the outermost shell. That is 2 comma 7. So 7 means they require one electron to complete their octet, right? For example, chlorine, atomic number 17, that is 2 comma 8 comma 7. So it also requires one electron to complete its octet. And hydrogen also requires one electron to complete its duplet. For example, if I just give one more electron to this hydrogen, it will become H negative. And I have told you that this H negative, it is known as hydride ion, right?
So,
Yes,
And
sir.
similarly, if I just take the fluorine, if I give one more electron to this, it will become F negative. That is known as fluoride ion.
yes, sir.
So can you tell me what happened because of this? When hydrogen gains one electron, its duplet gets completed. It completes duplet, two electron in the valence shell. And when fluorine gains one electron, it completes its octet. There are 8 electrons. So
Yes,
both
sir.
become stable. So that is why both have similar electronic configuration. Got it?
Yes. So I didn't understand this question, so I asked my sister. She said its position is anomalous or something like that.
Yeah, hydrogen has anomalous position. That's why it resembles with the alkali metals, and similarly it resembles with the halogens. But along with that, it differs from the alkali metals, which I have already given you the differences, and it also differs from the halogens. So that's why hydrogen has anomalous position. It has anomalous position in the periodic table. That means neither we can just keep it in group first, nor we can keep it in group 17. So that's why it is just it has separate position. It is just at the top of the periodic table. So that's why we are studying it with a separate chapter, separate name, separate unit, that is the hydrogen, right?
So,
Exactly. I have already also told a term that this, do you remember that this term? I have told you that hydrogen is known as a ruggy element.
no,
Do you remember
okay.
this?
What's it?
No, sir.
I have told you this hydrogen
Rogue.
element. Ruggy
Yeah,
means,
sir told this.
yeah, yeah. Ruggy means
I
that
don't
it
know.
has anomalous position. Anomalous position. It resembles with the alkali metals. It resembles with the halogens, and it also differs from the alkali metals and also from the halogens. So that's why it's called a ruggy element.
So,
Right?
yes. Sir.
Okay. Any more question? Any doubt?
No. Sir.
Okay, then let's stop today's lecture here. Have a nice day ahead.
Thank you, sir. Bye,
Thank you,
sir.
sir. Bye,
Thank you,
sir.
sir. Bye, sir.